In this lab, we're going to investigate the relationship between the period of a pendulum and the acceleration due to gravity. Now, that here on Earth, that seems like an impossible feat. However, if we take advantage of the inclined plane, we can change the effective value of gravity by changing the angle of the inclined plane. So for example, right now this is at about 90 degrees. So this pendulum here should swing back and forth as it normally would under the influence of gravity with an acceleration of 9.8 meters per second squared. We can vary the effective gravity like this, and if we know the angle, theta, of this incline, we can figure out the effective acceleration due to gravity by taking 9.81 meters per second squared multiplied by the sine of the angle. So for example, when it's horizontal, the sine of 0 degrees will be 0, so we get 0g. So the pendulum should not swing back and forth. When the surface here is vertical, the sine of 90 is 1, so we should get the expected 9.81 meters per second squared. Okay, I figured this out by looking at the components of g, where the surface of this incline is the x-axis, and then perpendicular to that surface is the y-axis. So breaking g up into its x and y parts and using trigonometry, you can see that the component of the acceleration due to gravity along this surface is equal to the acceleration due to gravity, 9.81 meters per second squared, multiplied by the sine of the angle of the incline. Now, to allow this to glide with very little friction, okay, I'm going to turn on an air source here by flipping this switch. And then it will glide along this board with very little friction. I'm going to be using a stopwatch to measure the period.